Okay, this is a video about a skill that we're going to go ahead and apply very soon, called taking the square root of both sides to solve anything that is raised to the second power. And we're going to take a look at why this thing works and why it's so readily used in mathematics. So first of all, we take an equation like x squared equals 9. And we could do this by armchair mathematics and be like, okay, I already know what the answer is for x, but let's explore the entire process just so we get a firm grasp on what's happening. So in the first semester, we did something called raising each side to the reciprocal, right? And when we raised each side to the reciprocal, we did this whole exercise here, and we knew that when we were raising each side to the reciprocal, 2 times 1/2 was going to go ahead and equal 1, so that gave us x to the first power equals, and then we just kind of like punch this into our calculator and whatnot because it was a very nebulous concept for us at the time, and we got x equals 3. So what we're going to do is that we're going to realize that there's more, really more gravity to this concept when we take the square root of both sides and explore it a little bit further, just momentarily in this video before we really start applying it to some equations. So starting again with something of this sort where we'd have x squared equals, let's go right back to the 9 there. And basically what it comes down to is that raising something to the 1/2 power is the same thing as taking the square root. So if I were to go ahead and put off to the side here something, is that if I were to say, and look in the upper left hand corner here, is that the square root of x equals x raised to the 1/2 power. So, but oftentimes we use the square root just because it's very convenient and we're familiar with the symbol. So to do this thing out, what we have to do is that we have to take the square root of both sides, and this is going to leave us with kind of a funny situation that we need to take a look at. So x squared, okay, with this taking the square root of that is much like this guy right here. So this is going to give us just x on the left-hand side. However, on the right-hand side, we have to go ahead and account for a positive and negative scenario, plus or minus 3. Now, why would that happen? Why would we have to go ahead and have a plus or minus number? Because if we look at the original again, both answers, plus or positive 3 and negative 3, would satisfy this equation right here. So let's go ahead and take a look. Plugging both solutions in is that I would get the following. I would get positive 3 squared equals 9. 9 equals 9, which is true. So that works. That takes care of the positive portion. However, does the negative portion work as well? And so, if I were to go ahead and put negative 3 squared equals 9, I know that a negative times a negative is going to be a positive, so a negative 3 times a negative 3 is 9. So 9 equals 9, so I know that that is true. And that's the reason why, when we're solving by taking the square root of each side, we have to go ahead and we have to put this positive or negative sign right here to the solution in which does not contain a square. So one more example over here in the corner here is that if I were solving this x squared equals, let's go 64, and I took the square root of each side like so, I would get x equals plus or minus 8. So again, that's just a little bit of background of why we get the plus or minus sign and why this technique works. So thank you for watching, and that's how you do that.